bonding. Okay, so first things first, you need to know what is ionic bonding. This could be asked as a definition. So ionic bonding, or an ionic bond, is the electrostatic, so that's a key word, between positive and negative ions. So the word electrostatic just means a force of attraction between positive and negative ion. Okay, so it's between a cation and an anion, which is called a negative ion. Okay, the other key point that you need to know about ionic bonding, it is a bond between a metal and a non-metal. How do you know the metals? The metals are found to the left of the periodic table, okay, and the non-metals are found to the right of the periodic table, okay, the right of the step lines. Have a look at my previous video to see what I'm talking about there. And the final point I must emphasize is that in ionic bonding, the electrons are being donated from the metals to the non-metals. Do not use the word share in your exam. The metals give or donate their electrons to the non-metals. Okay? Now, for ionic bonding, you can be asked to draw dot and cross diagrams to show what's happening. Okay? You will need your periodic table to help you with this. So what I have here are the atomic numbers. Okay? So potassium has 19 electrons, which means that 2 go on the first shell, 8 goes on the next shell, that's 10, another 8, that's 18, which means the outer shell has 1 electron, as potassium is found in group 1. Okay, and that should say fluorine. Okay, fluorine is in group 7, it has 9 electrons, therefore it is 2, 7. Okay, so we're just going to use the outer shell. So as it suggests, it's a dot and cross diagram. This is going to be my potassium. So I'm going to use a cross for my potassium. Notice I don't need to draw the inner shell. We're trying to save time. Okay, time is important. So next up, we have our fluorine, which now has 7 electrons on its outer shell. So I have 2, 4, 6, 7. Okay, so that is my before. Okay, now the first thing you need to ask yourself is potassium stable? It's not stable as its outer shell is not full. So what can happen is that it will need to either gain 7 more to have a full outer shell, or it could lose 1 electron, and this is now the new outer shell. That third shell would now be the new outer shell and therefore being stable. Potassium needs 1 more electron. Okay, so what will happen is you're going to transfer the electron. Please look at my arrow. It is being transferred from the potassium going to the fluorine. So what you end up having is potassium being here and fluorine being there, with the outer shell being full. Okay, and it's now stable. Notice one of them is now a cross. Now it's important that you do not forget your charges. Now this tends to be an issue for a lot of kids, right? Because potassium has given an electron and electrons are negative, the potassium which is left back is positive. Because fluorine has gained an electron, it's now gained a negative particle, therefore fluorine is now negative. Now these are no longer atoms, these are ions, and there's an attraction between that positive ion and that negative ion. It's a match made in heaven, and that attraction results in the electrostatic force. Okay, it results in that electrostatic force. So just to be clear, very, very clear, okay, potassium started off with 19 protons. Okay, but now it has 18 electrons. Okay, so therefore it's minus 18 and a positive 19, which gives it an overall charge of plus 1. That's why potassium is positive 1. In this scenario, fluorine has 9 protons, okay, and it also, well, it now has gained an electron, therefore it is now 10 electrons, which is why it is now negative, okay. This is positive 9, that's negative, which gives it an overall charge of minus 1, okay. Good, let's try another one. Magnesium and sulfur. Magnesium, 12 electrons, therefore it's going to be 2, 8, 2. Sulfur is going to be 2, 8, 6, found in group 6. We're just going to use our outer shell only. So 1, 2, that's my magnesium. Okay, this is now going to be my sulfur. So I have 1, 2, 3, 4, 5, 6. Sorry, 6, and that's therefore my sulfur. And what you end up with is neither of them is stable. So magnesium needs to lose 2 electrons. So there's my first electron being lost. Here's my second electron being lost. Okay. Now it results in magnesium having a charge. See if you can think what the charge is. Okay, based on what you've just watched. And sulfur is now an ion. Will now have that 2 extra electron, and therefore what charge will it have? So let's go back here. It's going to be 2 plus as it has lost 2 electrons, and it's going to be 2 minus as it has gained 2 electrons. Okay, and again, opposite attract, that force of attraction, electrostatic force of attraction. I've used 1 magnesium and I've used 1 sulfur. Right, if you look at our writing formula video, you'll notice that equal and opposite, they cancel out. We've only used 1, so you now have the formula MgS, which is called magnesium sulfide. Let's look at another scenario between potassium and sulfur. Electronic configuration 2, 8, 8, 1. 2 on the first shell, 8 on the next, 8 on the next, 1 on the last one. This is going to be 2, 8, 6. Now this is a slightly different scenario. Let's draw the sulfur first. Sulfur is going to have 6 electrons. 2, 4, 6 electrons. Not stable. It needs 2 electrons. Potassium, let's draw the first potassium, has 1 electron. Not stable. It needs to lose 1. So when potassium has lost its electron to sulfur, this potassium is now okay. However, sulfur is not okay. It needs some more electron. So it says to the potassium, do you not have a next friend that can come in, right? Or that needs a next electron? Potassium said, of course, I have a next brethren. Roll up. So potassium is now rolling up with that next electron. Okay. I need to get rid of that electron to sulfur. So now what you have is a scenario where 2 potassium is required to be bonded with 1 sulfur. So now you end up with 2 potassium. Think about the charges that they will have. I'll come back to that. And you have the sulfur here, which is now stable. Everybody's now stable. Okay, what charge will this have? 2 minus, and each potassium will have a plus charge because each one has lost an electron. Alright, and we know that opposites attract. Now, because I've used 2 potassium, so it's going to be K lowercase 2 S, potassium sulfide. Okay, good. And that's where formula writing is coming from. My previous video where we did the stop, drop, and swap. We will do one more. Lithium and nitrogen. So lithium is 2, 1. It's a metal. Nitrogen is 2, 5. So 1, 2, 3, 4, 5. Nitrogen is not stable. Lithium has 1 electron on the outer shell. Okay, so what needs to happen is lithium needs to lose 1. Lithium is fine, but nitrogen is not fine. Says to lithium, do you not have any other lithium friends that needs to lose 1 electron? Lithium responds, yes I do. Call in one more of his brethren. Come in. Let's go bond. Right? That will have 1 electron on the outer shell. Drags that across. Transfers, rather. Nitrogen, still not happy. Says to the lithium, do you not have a next friend? I need 1 more electron. How do you know you need 1 more electron? Because it's now, well, it was 2,5. It needs 3 electron. Call in 1 more of his lithium friend. Hey, let's go to a bonding party. Here you go. Okay? Everybody's now okay. So lithium, it takes 3 lithium, each having a plus charge, to be bonded with a nitrogen, 1 single nitrogen, with now 3 dots. Okay, and that's now a 3 minus charge. What they're looking for is to become 0, overall 0. So what you now have here is Li3N, lithium nitride. So the best way to put all of this together is to have a go at a question like that. Okay, so you can pause the video, have a go at a question like that, and see how you get along. Okay, best thing to do. All right, have a lovely evening, everyone. Bye.